In this video, actually, we're going to do a few examples using JFET. So let's take example 1. Let's assume we have a JFET produces gate current of, I don't know, 10 nanoamps when the gate is reversed bias with 8 volts or 10 volts, I don't know. Assume we have that. Can you determine now the resistance between, let's look at between the gate and the source. So what we know is actually the gate current, that's I sub G. And remember, we always said I sub G is really small, almost zero for the calculation. So for this, we are using a small current. I'm using 10 nano, that's times 10 to the negative 9 amps. And VGS here is equal to 10 volts. Its reverse bias is actually and if you recall Ohm's law, it says if you have a resistor here, this is the voltage across the resistor, V, this is the current going through it. Ohm's law says V equals I times R, which means R equals the voltage divided by I. Well, we're going to use the same thing here, except we call that resistor, we're talking about a JFET here. We know what the current going in here. We know what the voltage here. So the resistor between the gate and the source should equal the voltage across, which is VGS, divided by the current through it, which is I sub G, the gate current. So in this case, that will be what? What was my voltage? 10 volts. What was my current? 10 times 10 to the negative 9. So when you divide them, that's what? 10 to the 9. So that's how big that resistor. 9 zeros. Ohms. 1 gigaohm. So that impedance, that we said FETs are famous to have a large input resistance. So we're talking about 1 gigaohm resistance. That's the first example. Let's try another example here. Example 2. In the last video, we dealt with a JFET that I said, let's assume this JFET has IDSS, that's the maximum current going through the drain, the short circuit here, is equal to 10 milliamp. And the pinch-off voltage, VP, 4 volts. In case you forgot what the pinch-off voltage, quickly, let me just take a clean sheet of paper. This is when you take an N-type material here, and you put a P section here, positive and positive. And these two The gates are connected together. That's your gate here, that's your drain, and that's your source here. As the pinch-off voltage is the voltage that's going to make this depletion area touches that depletion area, so the current doesn't really change after that going right there because you block that channel there. So the pinch-off voltage is 4 volts here. And the question, can you calculate I sub D? And let's give you some values. I'll just do some strange values. We'll start with VGS here first equals 0. Then we'll do it when VGS equals 1.5. Then we'll do it when VGS equals, that's a negative here, negative 4. So the first one, that's part A. We know the equation to use. I sub D equals I sub DSS times 1 minus VGS over VP. And you're going to square that. It is actually not by VP. If you look at my notes, it says divided by VGS max, and VGS max is the absolute value, negative VP. So that really, if you do the math, I'm going to put a negative value here. So what is that equal to? I sub DSS, which is 10 milliamp. It's 1 minus, and VGS is 0. 0 over negative 4. So I should put negative VP here, because pinch off is positive there. So that will give me what? 10 milliamp. Now what happens in part B when VGS equals negative 1.5? So I sub D is going to be I sub DSS, again, 1 minus VGS over negative VP. If I use, by the way, VP negative, then I don't have to put the negative value there. Remember, your largest current you're going to have is this is the largest, that's the maximum current. You will never have a current larger than this in this JFET. So any answer that gives you a value larger than this can't be larger than that. Some people won't give you VP, they give it to you as positive, others as negative. You want to make sure this value, the ratio of this to this, has to be actually always positive, because you need to subtract that number from it. So I sub D equals I sub DSS, which is 10 milliamp, 1 minus VGS, which is negative 1.5, divided by what? Negative 4, and we're going to square that. You do the math. Where's my calculator here? That's 1 minus, there's my 10 times parentheses 1 minus 1.5 divided by 4, and I need to square that to the power of 2. I got 3.9 milliamp. And part C, if you let VGS equals negative 4, which is that value, I should have a 0. Then I sub D is going to be 10 milliamp, 1 minus VGS, which is what? Negative 4, negative VP, that's a negative 4, square it, and that will give me a 0 amp. Notice as VGS became more and more negative, the current started to shrink, less and less current going through it. Let's try another example. Example 3. Let's say we have this circuit. We have VDD equals 15 volts. We have a resistor here, I don't know, of 3K. And pick a value for these. This is, I'm not even going to give you a number for this. We'll call it R gate, R sub G. I'll call this R source. And let's assume the voltage right here plus to minus 2 volts. Here we go. I sub DSS is given to us to be 10 milliamp. And VP, I'm going to give it to you as a negative here, negative 2 volts. So now when I go back to the equation for the current, I'm not going to put a negative here. I just want that to be plus. So when I put that, it's not going to be negative, negative. It's going to be negative 2 for negative VP. Just some people give you VP as positive, others give you VP as negative. So now let's calculate that. Can you tell me, can you find the question here, what is I sub D and what is VDS? VDS is the voltage between the drain and the source. Well, to find I sub D, here's I sub D, is equal to I sub DSS, which is I have that number, times 1 minus VGS over VP squared. I have that number. VP is given to me. This is given to me. The problem is I don't know what VGS. Well, VGS is this, the gate here. That's VGS right there. So if I do KVL here, Kirchhoff voltage law, it says, I'm going to use plus to minus as positive, VGS plus 2 volts, sorry, that's a volt here, that's 2 volts here, plus, since we said the current is 0 here, 0 times R sub G should equal to 0. That tells me VGS here is equal to negative 2 volts. I should have picked a value beside negative 2. You know what? Let me make VP for this example negative 3. Let's change VP to negative 3 instead of 2. So now, I don't want these numbers to be the same. So can you calculate the current? What is I sub D? I sub D is going to be 10 milliamp times 1 minus, what's VGS? Negative 2. What's VP? Negative 3. Notice that number becomes a plus squared. So that's 2/3. What's 1 minus 2/3? That's 1/3 squared to 1/9. That's 10 over 9 milliamp. Now if I know that, can I find VDS? Well, I know what VS here. VS is 2 volts. I gave you that one. Do I know what VD? The voltage right here. Well, VD should equal the 15 volts, which is VDD, that's the source, minus the drop here, which is 3K, times I sub D, and I sub D is 10 divided by 9 milliamp. The K and the millis will cancel each other out. So that will be what? 15 minus 30 over 9. 11 2/3. So what's VDS? It's VD minus VS, and VD is equal to 11 2/3 minus VS, which is 2, that's 9 2/3 volts. That is the whole example. One more, then I have to leave the room. There's a class coming in after me. Let's say we have VDD here, and I'll give you a number equals, I don't know, I'll think of a number. I have R sub D here, unknown. Oh, I don't know why I drew that one. This is R sub S. So assume we know, so this is example 4. We know I sub DSS to equal 5 milliamp. I'm giving you that, given these things. Pinch off voltage is negative 4 volts. I sub D is equal to 2 milliamp. And VDS, that's the voltage right here. I'm giving you that voltage. VDS equals, I don't know, 8 volts. Let's find R sub D, R sub S, VD, VS. Well, there's a little problem here. I know I sub D and I know I sub DSS and I know VP. That means I can find VGS if I need it. How? I sub D is equal to I sub DSS times 1 minus VGS over VP, and you square it. Notice I didn't put minus again because I'm giving you VP as negative. So that's I sub DSS, which is what, 5 milli. I sub D is 2 milli. 1 minus VGS, which is unknown, over what? Negative 4, square it. That's 0.4 if you divide it by 5, equals 1 minus VGS over negative 4 squared. You can take the square root of both sides. So if we take the square root of both sides, what's the square root of 0.4? Square root of 0.4 is 0.63. 2 equal 1. There's be a plus VGS. One plus VGS over 4. My mistake here, over 4 here. So if you take the 1 to this side, it becomes a negative. Negative 0.368 equals VGS over 4. Multiply both sides by 4, you have VGS equals negative 1.47. Well, that's good, because now I can find what R sub S is. How do you find R sub S? Well, if we do KVL here, this is VGS. KVL here says VGS plus R sub S times I sub D is equal to 0. Well, I know VGS, which is negative 1.47, plus R sub S, which is unknown, times I sub D, which is 2 milliamp, should equal to 0. So R sub S equals 1.47 divided by 2 milli, which is divided by 2, 1.47 EE to the negative 3, divided by 2 milliamp, 1.47 the milli is gone here, just VG, 1.47 divided by, not milli, divided by 2 to the negative 3. 735. Okay. Do I know what VD is? Well, if I know what this, I know what VS. One of the question, what is VS? So VS now equals R sub S times I sub D, which is 735 times 2 milliamp. I'm just finishing the video. Give me 1 minute. Yep. Okay, just give me a minute. It's 1.47, which means VD is going to equal to VS plus VDS, which is 8 plus 1.47, and that's equal to 9.47 volts. We're making progress. If I know that, and I know VDD, let's pick a number for VDD. Let's say VDD is, I don't know, 10 volts. So what's R sub D? Well, we know 10 is equal to, or 10 minus R sub D times I sub D is equal the voltage right there, which is 9.47 volts. We know what I sub D is, 10 minus R sub D, which is unknown, times 2 milliamp equals 9.47. And quick math calculation here, 10 minus 9.47 divided by 2 to the negative 3, and we have R sub D equal to 265 ohms. I'll stop the video now because there's a class coming after me.